Hello, guys, and welcome to our first lecture in physics for grade 12. Today's lesson, we will talk about electric charge, or exactly the electrostatics. So, the focus question for today, why does rubbing your shoes on the carpet lead to a shock when you touch a metal doorknob? Maybe you noticed in a dry day in the winter, when you catch the doorknob, you felt with a little shock of electricity. That's what we called it, the electrostatics. Or maybe when you touch your friend in a dry day, and also you can felt with a little shock of electricity. This is also the electrostatics. So that's what we will study for today. The new words for today that we will learn is the electrostatics, neutral, insulator, and conductor. So every word in physics, as we learned, every word in physics that we will study, we should put a definition for it. So today, because of the studying of the electrostatics, we should put a definition for the electrostatics. The definition is electrostatics is the study of electric charges that can be collected and held in one place. This is the definition of electrostatics is the study of electric charges that can be collected and held in one place. Over the years, the scientists determined that we have two types of electric charges, which is positive and negative charges. So we have two types or two kinds of electric charges, which is positive and negative charges. Two objects with like charges always repel each other, and two objects with unlike charges always attract each other. What does that mean? We said that we have two kinds of the charges. So if we have an object with a negative charge near to the object that also has a negative charge, the two objects they will repel each other. Why? Because the two objects with like charges always repel each other. And if we have an object that has a positive charge near to the another object that also has a positive charge, also they will repel each other. As we said, two objects with like charges always repel each other. Now, if we have an object that has negative charge near to another one which has a positive charge, the two objects with unlike charges always attract each other. So they will attract each other if they have the unlike charges. If you rub your hair with a balloon, it will stand on end because of the electrostatic force between your hair and the oppositely charged balloon. If you rub your hair with a balloon, it will stand on end because of the electrostatic force between your hair and the oppositely charged balloon. What does that mean? Suppose that we have a man here. I know I'm terrible with drawing, but suppose that we have a man here, and here is his hair. So, if we rub his hair with a balloon, we will notice that his hair, that also the man, this is the second one, we will notice that her hair will stand on end. Why does that happen? That happens because of the rubbing the hair with the balloon. The hair will gain the hair will gain a charge is opposite to the charge of the balloon. So the hair will attract to the balloon, and after that the hair will stand on end. I hope you understand it. Now we have a microscopic view of charge. All materials contain negatively charged particles called electrons. In addition, each atom has a massive positively charged called nucleus. All the materials contain negatively charged particles called electrons. In addition, each atom has a massive positively charged called nucleus. What does that mean? Look, if we have here an object, we know that every object on Earth that has electrons, the electrons with negative charge, of course. So let's suppose that we have the electrons here. Every object has a massive positive, we called it nucleus. That's what we called it, the nucleus. Here we have the atom and here we have the nucleus. The nucleus has inside it the proton, which is positive charge, and also has the neutron, which is neutral charge. So the nucleus that has the positive charge, why does the nucleus has the positive charge? Because it has the proton, which is positive. So in every object on Earth that we has the electrons and we have the protons and the neutrons. The electrons, of course, it has the negative charge, and the protons that will have the positive charge. So here all materials contain negatively charged particles called electrons. And in addition, each atom has a massive positively charged, we called it nucleus. In a neutral object, the amount of negative charge exactly balances the amount of positive charge. That means we have objects in neutral. What's the meaning of neutral objects? We can put a definition for a neutral object, which is, sorry, the neutral object is the amount of negative charge exactly balances the amount of positive charge. This is the definition for neutral object. That means the electrons is exactly balances the protons, which is positive charge. Now, with the addition of energy, the outer electrons can be removed from atoms. With the energy, the atoms can be the electrons, sorry, can be removed from the atoms. How it could be? Now we will learn how is that. An atom missing electrons has an overall positive charge. Consequently, any matter made of these electron deficient atoms is positively charged. That means every atom that will missing the electrons, it will be a positive charge. And here vice versa. The freed electrons can remain unattached or become attached to other atoms, resulting in negatively charged particles. What does these two notes mean? That means when the atom missing the electrons, it will be positive charge. And the atom will gain the electrons, it will be a negative charge. Again, this is important. An atom that missing electrons has an overall positive charge. And if the atom will gain the electrons, it will has the negative charge. If two neutral objects are rubbed together, each can become charged. We know now the neutral object, when we said the neutral object, we know that the object has exactly the same balance, the for the negative charge and the positive charge. So if we have two neutral objects of them and rubbed rubbed them together, each can become charged. The final note that we have for today: charge is conserved, that is, individual charge are never created or destroyed. Charge is conserved. What does that mean? That means that is, individual charges are never created or destroyed. The positive and negative charges are separated through a transfer of electrons. And this is also important. The charges are never created or destroyed. So the charges are just separate through a transfer of electrons. That means we cannot create the electrons, we cannot destroy the electrons, it just separated from the atoms. Until here, we reach to the final of our lecture. See you soon in another one.